Hello students, welcome back to our chapter called LPP. In this module, we are going to see another method to solve LPP graphically. Let's see what that method is. So the method is called isoprofit or isocost method. Isoprofit for maximization problem and isocost for minimization problem. So let's see what are the steps. The first step says that draw all the lines corresponding to all the constraints and shade the feasible region. So this step is exactly similar to corner point method. Next step is different, that is draw a line z equal to ax1 plus by1 where x1 y1 is any point inside the feasible region. So this step is really important. So after drawing this line is called as initial isoprofit or isocost line. So let's see next step. Third step says that if the objective function is of maximization type, then the isoprofit line is moved away from the origin. Remember, whenever the problem is of maximization, isoprofit line is moved away from the origin, parallel to itself till the extreme feasible point is attained. That is, isoprofit line will always give us maximum value of z. Now, next step is for minimization, that is we call as isocost line. Remember, isocost line is always moved towards the origin, not away from the origin. So isocost line we moved towards the origin till extreme point is attained, and at that point we will get minimum value of z. So with this in mind, let's start to apply all these steps to our problem. So our question says maximize z equal to 11x plus 8y subject to constraints x less than or equal to 4, x plus y less than or equal to 6, y less than or equal to 6, and non-negativity constraints. So let's see how do we solve using isoprofit method. Now let's plot our table first. First we will convert each inequality into equality, that is equation. So x less than or equal to 4, we'll write it as x equal to 4. Next, intersection with x-axis and y-axis. For that we'll put y equal to 0 first. So we'll get x as 0, and since this is a line parallel to y-axis, we won't find any intersection with y-axis. And what is the feasible region? Apply origin test and we will get 0 as the answer. So 0 less than or equal to 4 satisfies inequality, hence feasible region will be origin side. Similarly, for other inequalities we'll calculate all these things, that is y equal to 6, intersection with x-axis is none since it is parallel to x-axis, and intersection with y-axis will be 0, 6, and feasible region origin test will again be true. So feasible region is origin side. And the last inequality given is x plus y less than or equal to 6, that is equation is x plus y equal to 6. 2 points will be 6, 0 and 0, 6, and feasible region again will be on origin side. I hope this table you have understood. So after this, let's plot all these inequalities on our graph and find feasible region. So let's plot each line, that is first x equal to 4, next y equal to 6, and next x plus y less than 6, less than or equal to 6. So these are all the lines we wanted. And now since the feasible region for all lines is origin side, the shaded region or feasible region will be as shown in the diagram. The shaded region is whole feasible region. And after that, we will apply our isoprofit method. So for that, consider any point inside feasible region. So let that point be 2, 2. So put 2, 2 in our objective function and evaluate it. So z at 2, 2 will be, we will call it as z1. That will be 11 into 2 plus 8 into 2. That will give us 22 plus 16, that is 38. So now we will plot initial isoprofit line as z1, that is 11x plus 8y equal to 38. So we have plotted this line as shown in the diagram. So Z1 is our initial isoprofit line. Now remember, since the objective function is of maximization type, we will draw lines parallel to isoprofit line away from the origin. So we will draw all the lines away from the origin. So let's start to draw lines away from the origin parallel to initial isoprofit line. So Z2 is parallel to this, Z3 is parallel to this, and we can see that B is the extreme corner point of the feasible region which lies on our isoprofit line. So B is a required point, and at B we get maximum value for our objective function, and that is what our solution is. So this is initial isoprofit line required, and our point required will be B4, 2. So Z3 attains maximum value at B, and what are coordinates of B? 4, 2. So since Z3 passes through B, we will calculate objective function value at B, that is 11 into 4 plus 8 into 2, that will give us 60. And this is, students, optimum solution for our objective function, and its maximum value is Z, that is 60. So this is how we apply isoprofit method to our problems. Advantage is we need not evaluate Z at each of the corner points. So with this discussion, we will end this module. Thank you.